Right, so hi everybody. Thanks for joining today. I'm Finlay Asher. I'm co-founder of Safe Landing, which is a group for climate-concerned aviation workers. This could be pilots, it could be engineers like me. I'm an aerospace engineer. We've also got cabin crew, air traffic controllers, but we're really open to anybody in the aviation sector that's interested in the climate impact of flying and what we think we need to do about it to transform the industry. You can find out more. We've got a website, safelanding.org with a hyphen in the middle, or info@safelanding.org is our email address. So please, if you want to reach out to our group, get involved with anything, if you've got any suggestions for future talks, please get in touch and let us know what you're interested in. So just a little background to the group and what our demands are that we kind of came up with collectively. So this is towards industry leaders, but also government leaders as well. So firstly, we want to be honest about the total environmental impact of flying. That includes not playing down the carbon emissions from our sector, but also being clear about the non-carbon emissions, the non-CO2 global warming impact. And Guillermo's going to discuss some of that today with respect to the space sector. The next thing is to be realistic about the limits of technology to solve that problem. So don't just greenwash with this technology is possible, problem solved, and technology or fuels. And I think we're going to kind of get into a bit of that as well, because the space sector is looking at some of the same alternative fuels that the aviation industry might look at. We also want to be transparent about future regulations that we think are necessary to reduce emissions. So stuff that like looking at constraints on air traffic and capacity at airports, and stuff like policies like frequent flyer levy, taxes, and other things that will be required to move the industry in the right direction. And then we want a plan that accounts for that and supports workers through that transition. And we're also encouraging aviation workers and trade unions to think about the climate issue and the transition of the sector as well for themselves. And we've got this petition for an aviation workers climate assembly, much like a citizens assembly, and we're actively talking to different trade unions about that. So if you're interested in that, check out the worker assembly section of our website. So today we've got Guillermo with us. He's recently moved to Scotland, and he's an aerospace engineer who's been working on space rockets, and is looking at the non-CO2 environmental impacts of spaceflight. So Guillermo, I'll pass to you. And yeah, as I said, we'll have about 25 minutes or so presentation, and then there'll be plenty of time for questions at the end. So please feel free to put questions in as we go along, and I'll be checking those out. Yeah, so over to you, Guillermo.
Perfect. Thank you for introducing Finlay. Are you all seeing the presentation? Is there?
Yep, that's
okay,
good.
Perfect. Great. Well, good afternoon, everyone. Thank you all for attending the presentation. So I'm Guillermo. Well, recently was introduced also to Safe Landing after speaking with Finlay on also these non-CO2 impacts. And we thought it would be a good idea to present to all of you on my research on the environmental sustainability of spaceflight. So I hope you enjoy it. This somehow all started because well, I was working on a European project on the design of ecologically and economically sustainable launchers called Ascension, where naturally, well, this question arose on what is really the environmental impact of rockets and how can it be mitigated, as what changes we can do in the design and all these things. So the first thing that really pops up, like when you start to really look into this question of space sustainability, is actually more on the in-space sustainability. So there's currently big efforts to kind of tackle this with space debris, which is actually a big issue. So up to now, we were leaving huge amounts of satellites and rocket stages in space, which at the end, they eventually bump against each other at quite astronomical speeds. So they can create even more debris. And at the end, it's kind of risk the escalation to a point of no return, where we just won't be able to use space anymore and just becomes unusable in that sense. So naturally, I mean, because of its kind of very big hazards to the space industry, this has been a quite large focus by the space agencies. And there are some efforts already, some regulations, well, mostly standards coming in, and so things are moving in that way. But still, nevertheless, like many experts are still think that current efforts are still insufficient, and that we may be already passing a point of and kind of this inflection point where we basically, if we stop launching, still things will, the amount of debris will continue to increase. So it's quite critical in that sense, especially now with the space sector is changing very rapidly. There's new mega constellations popping up. I will speak a bit later about that. So it's big. But in terms of the sustainability, well, as you may know, you already see it from this picture with this rocket launching off, and there's a huge cloud of smoke around it. Well, the sustainability is not only about the in-space environment in that sense, but also you have to consider the in-earth sustainability on the environmental impacts that are caused here. And we found rather quickly that there's almost nothing up to now. There were things that were done before, like maybe 30 years ago on stratospheric ozone depletion, for example, caused by rockets, because this was of interest at that time when there was this problem with the stratosphere, with the ozone layer being depleted, where some people looked a bit on the rockets, and it was just small. We were not launching that much. So, but it was kind of tackled in the past. But in terms of the current sustainability, in terms of the in-orbit things, in-space things, this is just starting. There's some, for example, in Europe, probably there's one of the only places where this is actively being looked at with the, for example, the Seasick in space, and there's other places there. But still, we still have a lot of, we still lack a lot of knowledge, especially from the atmospheric impact side on what's really going on. So, well, as you will see now, well, this, what I want to present now, this is somehow in early stages. I also recently started a PhD on that, so you may expect it to be quite new, everything. And there's many things to be done, so to really understand all this. But well, it's a first step in all this direction, the studies that have been done up to now. And I hope the feedback will be valuable, especially coming from the aviation community. I guess more people here are more involved there. Where this problematic is quite more extensive. The non-CO2 impacts, for example, are more known, and you are all aware about these climatic issues, especially in safe landing. So, well, just to introduce myself, just a bit. Well, I'm an aerospace engineer in training. I'm also I'm an early stage researcher in system aspects of reusable launchers for this European project called Ascension at the German Aerospace Center. And recently, in collaboration with that also, I started this PhD position in University of Strathclyde here in Glasgow on the uncertainty in environmental assessments of space systems. So before I worked briefly in demo space in space consultant in Spain, also in NLR, the Dutch Aerospace Center, for an internship, and I was involved in these universities. And my research, well, basically my work was largely focused on the rockets itself, on the guidance of the rockets for reusable rockets to land them everywhere. I was also quite convinced also on the sustainability of reusing the rockets in that sense, and so that has been most of my work up to now. But of course, with this project, well, it came the environmental part there, and then my research focused more on this in this direction. So just to introduce a bit to the space sector, because probably most of you are not very aware about it. So well, the space economy is kind of this multi-billion sector where there's many applications at the end from GPS, telecommunications, Earth observation, also for climate change monitoring. It's quite critical in that sense. And within it, the land sector is actually one of the small parts of it. It's just that small piece there that you can see, which sustains this kind of whole global economy, global space economy. And here things are changing quite quickly. In the past, well, there was a huge increase, especially with when the space shuttle was introduced, and then there was a kind of calm time where as the space shuttle was decommissioned, also in that sense. But now things are changing with the introduction of private companies, all this commercial space new space with, for example, the SpaceX or Rocket Labs or many other companies there, which are really changing things. And what's going to happen now, that's really unknown. So there's estimates that there's some forecasts by some institutes that this might actually increase a lot, and we might be in the brink of a huge growth in the space sector, and with it also with the launch rates. But it's quite unknown. We estimated in a previous study just from planned proposed launches and space projects that by 2030 this might increase by 80%. And of course, there's a lot of uncertainty around it. But this also may change. This is actually only considering the planned proposals, but there are even more kind of breakthrough applications on the horizon, as you may know from SpaceX, Elon Musk. So one of them is, you may be more familiar with this, but basically, for example, it's kind of the long-term kind of dream for like rockets in that sense, to eventually use rockets not only for launching things to space, but also using them for super fast intercontinental travel between different places around the world in under an hour. And this is something that might be technologically possible if eventually these reusable rockets, for example, they really kick off. We are already seeing them with SpaceX, with the reuse of Falcon 9. They are managing to reduce, for example, the space access cost by at least by half. Like they are really, it's really changing what is the economics of space travel. And if this continues that way, if we are able to reuse the rockets way significantly more, at the end, the costs of space access, which are actually mostly driven by indirect things in terms of how much we, well, the launch places itself, all the things that we need for the manufacturing processes and everything. If we are able to somehow use the rocket more, launch more, all these things will be very amortized over all their launches, and it could be reduced significantly. So SpaceX thinks that they could do it by a factor of 100, and that would be quite significant and might eventually lead to these applications becoming a reality in that sense. And also by launching so much, this is, I actually believe, to be what would lead to the highest launch rates if this ever happens in the future. Just going to anywhere in well, one can think of like moon missions and everything will become quite accessible. At the same time, there's even other applications. So for example, placing huge megastructures in space. So for example, solar panels, power satellites in orbit, which could help in terms of for climate mitigation, for renewable energy or things like that. And this could have some attractiveness in terms also, for example, that you could just power anywhere around the world, beam energy anywhere, especially for really remote regions as deserts, or one could think of even aircrafts, Airbus thinks that they can do this in that sense. And well, at the end, also when it comes to their sustainability, the environmental sustainability, it kind of also related to the land sector, to the land place itself. So like, well, not only also the production of the satellite and everything, but especially one of the bottlenecks is kind of the launch place, when you consider also the atmospheric impact, all the non-CO2 effects and stuff. When you kind of try to do an assessment in terms of the CO2 and environmental footprint, it might be showing that it could be, for example, more sustainable than using fossil fuels in that sense, and could reach eventually ground-based kind of life cycle environmental impacts. But still, there's this whole critical phase of, in terms of the launch, for example, the non-atmospheric issues, the non-CO2 atmospheric issues, where there's still a huge uncertainty, and so we really need to understand a bit what's happening there in order to really know about all this. So let's go a bit more in detail there, because, well, it's all this. I will try to explain a bit what's this problem with atmospheric impact of these rockets. So, well, as you know, well, there's this, at the end, when we launch a rocket or a space mission and everything, we consider the full life cycle behind. So the production and everything, which this, in terms of the climate impact, which is more or less the focus in this presentation, it emits some greenhouse gases, for example. It contributes to this effect. And at the same time, well, you have the rocket that then also travels through all the atmospheric layers, and also emits part of this to the and adds to this life cycle of the issue. At the same time, it also goes through the ozone layer. One of the things that was seen in the past rather soon is that it also leaves like a kind of small holes through the ozone layer, which also recovers quite rapidly, but still there's something there in terms of the impact of in the ozone layer. And also the other issues that are, but this is, well, at the end, this is not all of it. You also have to, when you account for these non-CO2 parts, things become a bit more complex. The issue is that up to now, there were not many studies on this. Now they are starting to appear, and it's been more of a focus. But to really compare with that, you could also kind of go for aviation. So in terms of aviation, maybe some of you are aware, there's this, the climatic impact it has is not only the CO2, but it's also there's also these constraints that are formed from the aerosols that are emitted, the water emissions also. So there's those ones have an important radiative forcing impact, which is also quite dependent even on meteorology and other weather conditions. And even then, there's also, for example, the emissions of nitrogen oxides, which affect in different ways. For aircrafts, it increases the amount of ozone, for example, while decreasing methane, but still the net effect is still a warming effect. And more or less, there's this kind of rough estimate that someone can do of these impacts being more or less at the end multiplying the effect of CO2 by 3, more or less. Of course, it's more complex than that. There's a lot of parameters that influence all this. But at the end, all this is quite dependent on where it's emitted. So this is in the troposphere. For rockets, it's going through all the other layers of the atmosphere, so one can expect it might be different. You can already go, for example, there were some studies in the past on what is like the impacts of supersonic aviation and how these non-CO2 effects have changed when you emit a bit higher altitudes, for example, in the stratosphere. So for supersonic aviation, there were, like, for example, a past study on what happens if you are using a fully hydrogen-based hypersonic aircraft, and well, at the end, only your emissions are only water. What would be the impacts from that? And it was seen that more or less, well, there's huge uncertainty also around it, but the equivalent, it will have like these stratospheric water emissions, it will have like an impact of maybe 8 to 20 times stronger than than compared to a conventional hydrocarbon-based aircraft traveling through the troposphere. So it's still rather important, only from the water emissions in that sense. So one can see that already the altitude influences changes a bit the picture. For rockets, this becomes more complex from what we know right now. So there's many factors influencing this. One of the things is in terms of the aerosol emissions. So this is some impurities that are left when you burn hydrocarbons. For rocket engines, they are just more inefficient than conventional aircraft engines. So they emit an order of magnitude of 1 or 2 times more than aircrafts, than conventional aircrafts, 2 orders of magnitude more or less. And when you emit this kind of aerosols of black carbon around in the stratosphere specifically, it leads to a sort of warming of the stratosphere, which is estimated to be 100,000 times more efficient than just an equivalent CO2 emission. And it ends up affecting the climate and also accelerating ozone loss in a way. But the effect on the climate is rather strange. So it doesn't mean that it's warming 100,000 times more the planet in that sense, but it has different influences depending on a local level. When you do all these stratospheric adjustments, this is some very complex thing of climate science, but when you do some things, you end up seeing different pictures where there's global cooling on some sides, warming on the other sides, and also affecting the whole atmospheric circulation in different ways. And one could even expect that one of the problems is remaining there up there in the stratosphere for a long time. It spreads around the world, and it might be affecting, for example, what is could reach, for example, the polar regions where black carbon emissions are a bit more concerning. Also, at the same time, there's the issue with nitrogen oxides, whereas for aircrafts it was increasing tropospheric ozone. For rockets, apparently it leads to a reduction in stratospheric ozone, and also has some warming influences because of chemistry that happens there. So it's also one of the concerning parts. And of course, the stratospheric water and other like aerosols and particles as chlorine that are emitted when you use solid rocket motors. So these all influences. There's also the issue with contrails or things that are happening, although this is rather unknown. Up to now, in the past, it was seen that the amount of this is called polar mesospheric clouds that are emitted quite high up, that are created high in the atmosphere. With the space shuttle, it was increasing significantly. And still the influences that could have in the climate is rather uncertain. And this is not all the full picture. So at the end, what comes up must come down. No? So the rocket stages and the satellites also, when they re-enter, they end up burning in the atmosphere. This is one of the active strategies to also like reduce space debris. One of the issues it has is that it's emitting kind of these debris particles, or also called like small smoke particles in the upper atmospheres. And the effects are still not really much quantified in this sense. So there's some indications that it might also reduce affect the stratospheric ozone. It might also influence the formation of these polar mesospheric clouds, or noctilucent clouds they call, and of course the climate in different ways. At the end, these aerosols that will, or particles that will stay there for a long time in the atmosphere. So, well, at the end, when you look at this, you see that it's quite complicated, the picture. And when it comes to the original question of how can we then like really design sustainable solutions or sustainable kind of launchers or even satellites in that sense, to this, it becomes quite complex. Because the thing is, like, one of the strategies that is mostly used and is the widely recognized as the most thorough strategy to use is what is called life cycle assessment. So to consider this full picture, not only what is the use, so not only the launch event, but also the production of the satellite or your rocket, the disposal, also the recycling, the transportation, everything. So to consider everything in an integrated way and to try to compare things with each other. So then you can see more or less, you can prevent any called burden shifting. So where you reduce somewhere, but you increase somewhere else. So for example, you can think of the comparison between a petrol car and a electric vehicle, no? That the electric vehicle doesn't emit when you are using it, which is actually great, no, for the cities and everything where more people are located. But still, they have some issues in the production phase. So the electricity is produced somehow with some energy. Can be fossil fuels, for example, and is still having an issue there, or the recycling of the battery or the material extraction. So at the end, to really compare things with respect to each other, you have to consider this full life cycle, and also in terms of what is called one functional unit. So one unit of what you really want to do. In terms of rockets, it can be a payload to a specific orbit, for example, or things like that. So it's difficult to really, so you can see already, well, you have to do this to consider everything together, but at the same time, then you also have to find a way of comparing the different cycles, phases with respect to each other. In terms of the climate change issue, for example, that we were speaking about, it's rather complicated to compare then what is the full life cycle, so the CO2 that you emit through the electricity consumption while you're producing some parts with for example, the black carbon that is emitted in the stratosphere, which acts in a different time scale, or the specific cloud that is formed, or the nitrogen oxide particle that is there. So there's this kind of CO2 equivalent metrics that can be used, but still it's well, it's also something that is quite seen in aviation. There's still maybe not the most adequate metric, because it depends on a lot of factors. It's kind of a simplification of the atmospheric impact that we try to make it. And it depends, for example, if you change, for example, the time frame to 20 years, 5 years, or 500 years, the relative importance of each emission changes significantly. And this might affect results significantly, and also introduces a huge new level of uncertainty in your assessments. So we try to more or less use this approach. So I mean, at the end is what we have now. We really need to make more scientific kind of breakthroughs to improve our theoretical understanding of what the whole atmospheric impact is. Also do experiments, because I mean, we also will need to even like check with maybe with another aircraft or something, like what happens in the atmosphere and what's the chemistry after these impacts. So but still we can kind of make an assessment with this kind of life cycle methodology and try to derive some things maybe on this. So we did a past study on just trying to consider different land scenarios and the impacts of different activities. So for example, of constellations, and based on the planned activities, so like planned mega constellations or other things, and also considering the baseline space activities, there's already a huge number of launch rates that might increase in the next years. And when you run these life cycle assessments in terms of the different impact categories and everything, you already see that what could be the environmental impact could be already increasing by at least more or less 1 order of magnitude in that sense. So what we thought would be negligence in terms of the negligible in terms of the space sector, that is not much what it does compared to other sectors. This might be changing quite rapidly now. We are already seeing these mega constellations that are being launched, like Starlink and everything, and this might change significantly in the next years. Also, this is not, as we talked before, there's also this more kind of speculative activities or more crazy activities, or doing earth-to-earth transportation, for example, using the aircraft for that. So we also run an analysis on just some preliminary assumptions on what could be the impact if we do that. And we already saw from just some networks that would be there in the world for some simplified assumptions in terms of how many people will be traveling and everything. We already see that it reaches some concerning levels in terms of, for example, stratospheric ozone depletion and the black carbon emissions with respect to our current emissions and also the planetary boundaries, which we can kind of define. Also, in terms of climate change, this is not accounting for these high altitude non-CO2 effects even, but still the impacts can seem to be quite high in that sense and reach concerning level. If you also go to all the plans, for example, SpaceX, the plans for doing Mars missions and all these things, you see already how the impacts increase even considerably and reaches the planetary boundaries, which really might be a big issue also in terms of black carbon emissions. So really throws some doubts in terms of the environmental feasibility of all these activities. But of course, it depends. The uncertainty is huge, and we still should really understand what's going on in order to really know. This also opens another dimension in terms of the social justice, of all these activities, like the differences, the inequalities in terms of these activities. So especially when space tourism is introduced, which is something that is starting very recently. For example, you can compare it with a usual approach that is done is to compare it with the emissions of an average European, which is already higher than the global average, but the emissions of an average European in terms of the whole year. And you can see that there's certain activities as an orbital flight, it's already quite high in terms of the simplified assumptions, not including these high altitude effects, even in ozone depletion. At the same time, this of course would be quite expensive, at least initially, and so only only very wealthier people could be able to do this. So this introduces this huge dimension in terms of this. And these findings were also seen by other researchers in terms of doing more, accounting for a bit more in terms of these high altitude effects of the launch emissions using other metrics. But they saw, for example, that after 3 years of these space tourism activities, they will reach 1/10. The impact of these launches would reach 1/10 of global aviation radiative forcing, and that for example, all the progress that has been done by the Montreal Protocol to control the Arctic ozone decline would be just undermined in 10 years. So this would become quite concerning. So after seeing all this, and also based on our initial question of how really can we design sustainably these launchers, there was this question of, well, how can we at least mitigate this impact? Because at the same time, we are, especially in Europe, like we are designing for new, like the next generation of launchers. For example, well, now it's Ariane 6, but we are even thinking a bit more ahead for the future reusable launchers. We are also not sure how well Ariane 6 and everything would perform in the commercial market, especially because it's changing very fast. With if Starship really flies in that way, it's planned for this year. Things could change very rapidly, and so we did a kind of assessment to try to compare different propellant choices or different reusable options that you could choose for. So, for example, landing your booster or using wings. And well, we already saw that things are quite big. Well, becomes quite complex in that sense. So, for example, these graphs are in terms of different the technology choices that you can use, different propellants of using hydrogen, using methane, kerosene, ammonia, for example. And still you can see that well, in terms of also in different recovery strategies and vehicles, you can see that here you can see one of the main kind of challenges with the reusability of your rockets. So the black line is just expendable, a conventional regular expendable rocket equivalent in that sense. And one of the issues when you introduce reusability is that because of the added mass that you have, because maybe of the wings or because of the propellant you have to burn, you end up emitting at more in that sense. And so then on the one side, you might be like decreasing what is the emissions coming from the production because it's more sustainable. No, you are not reusing you are not wasting your stages and every time. So there's savings you get from there, but still because of this added propellant that you have to consume, it might be that still is not really better in that sense compared to a equivalent expendable solution in that sense. So at least in global warming potential, and this is also not accounting for this high altitude effect, so one can expect because of the high altitude atmospheric issues, this might be even larger. The sustainability of, at least in global warming potential, of reusability is not really known, not really clear. So, well, just to conclude a bit on all this, what we saw from the studies is that the climate and environmental impact limits may constrain what is the intensive space activities in the near future or far future, and that the high uncertainty still remains on the atmospheric impact. We need to really do something there to really know. Also that the choice of what you use of your metrics, so global warming potential over 100 years or so changes a lot the issue, the impact, and that future regulatory constraints, one can expect that if these launches continue to increase, and also as the environmental crisis and the issues continue to develop, to unravel, at some point regulatory agencies might get more into the field. We already see it in the USA with the FAA. It's starting to, well, at least put some constraints in terms of the some launches that the SpaceX can do or things like that. And eventually it might be, for example, if you do intercontinental travel with rockets, it might be that it ends up internalizing climate change costs, for example, through maybe makes it mandatory to buy an emission certificate, for example, as in aviation. And based on these numbers that we were seeing before, like gigagrams of CO2 equivalent for a launch, that's basically it's almost as the launch cost itself eventually of just by internalizing with current CO2 price just on the CO2 emissions or the equivalent emissions that you get. So it can affect the business case significantly if this eventually happens. And of course, some mitigation might be possible, but there's different things that can be done, but it requires a considerable improvement of what we really know about atmospheric and the whole life cycle impacts. Otherwise, we might risk maybe we are using a very green material in one component of your launcher, but because maybe, I don't know, it's produced through beeswax. This is something I heard before, that maybe it's super green and sustainable in terms of all the other environmental impact categories, but maybe just slightly weights more or something like that. And because if the atmospheric issues are really that important, especially the non-CO2 parts, it might be that it's just not sustainable at all in that sense. So it's really important. At the end, this becomes quite tricky, all this part. So, well, just wanted to end just to mention safe landing. Maybe there's at the end, there's more dimensions because, I mean, the aerospace field is quite connected between aviation and space and everything. So maybe it's not only about the safe landing, but we have to consider also all the safe lands, orbit, and entry in that sense. And yes, that was everything. If there are any questions or feedback, I would appreciate it a lot.
Thanks very much, Guillermo. Yeah, there's a lot of interesting detail in there. So thanks for coming along and taking us through that. If anyone has any questions, please put your hand up and I'll get to you in order, or feel free to type any questions into the chat. If you don't want to read them out, and I can read them out and we can get onto them. I see there's not any questions so far. But yeah, if you want to put put up your hand, I'll get round to you. I just wanted to, I suppose, while people are having a think about that, a specific question I had was, you know, with aircraft, it matters about the weather conditions on the day in the location that the aircraft are flying. Is it for space launch? Is it kind of that actually you get through the weather conditions quite quickly and it has less of an impact, or does it kind of matter what the weather's like, and also is there an influence over just geographic location and time of day and that sort of thing?
Yes, no, it's I mean, it's quite important. It's quite an interesting question. I up to now, I don't think there's almost nothing like really like studying these differences in terms of methodology. But there's been I've been in discussions about this, and of course, it might be affecting at the end these contours that are formed for rockets. They're also big, and in the same way that it affects for global aviation, I think that for example, a contrail more in the night has a stronger climate impact than, for example, if it's in the during the day. One can expect similar issues. The thing is, like, also launch opportunities, they are quite constrained by your window, so they always happen like in a very specific time frame that you have to do it. But also there's others that are kind of more flexible, so it really depends on that. But of course, I mean, it can be an important part. At the same time, like one of the issues of this is that the emissions, they stay longer in the stratosphere, so it's not sure up to what degree it could have an effect, but probably in the effects in the troposphere for sure it's similar to aviation, maybe.
Okay, yeah, because it's with aviation, it could be kind of a few hours to a day at most, kind of for contrails, so it can make a difference if it's night or day. Okay, and yeah, no other questions for people, so I suppose I can ask another one as well. When we're looking at aircraft fuels, and we've got these alternative synthetic fuels, when we burn those, they burn cleaner and they produce less soot, which means that we think they produce less contrails, and then there's less global warming impact from the non-CO2. Is that something like, are the soot particles important, or are they kind of like of secondary importance? Really, you'd improve stuff at one atmospheric layer, but actually above it's water vapor that's more important, and you can't really change that with making your fuels burn cleaner.
So here, one of the big issues that is being seen, like I'm going to go back to this figure, just so more clear. One of the big issues that is seen is in terms of this exactly is also on the aerosols emissions of the hydrocarbons, for example, black carbon and everything. And there are studies, for example, up to now there's not much, but there are, for example, studies that, well, in general, like it is believed that, for example, if you use methane in your rocket, you are reducing a bit the amount of soot, but to the point that it becomes that significant, it's not entirely clear, because at the same time it might be a bit more inefficient in terms of for example, than using kerosene, so you also emit more. No, so there's always a balance there. And also the black carbon is quite is also one of the important environmental impacts for hydrocarbons, like also, at least order of magnitudes more than the other emissions. So to the point, depends on how much you reduce. Maybe with methane you can reduce 95% or so, but is that enough? It's not entirely clear even, because this is the thing, is one of the important ones, and it also depends on. Typically, the engines burn like very fuel rich, so it tends to form a bit more. And it might be that with methane still emitting a bit more, a bit slightly soot, a bit more, some soot because of this fuel rich composition. But there's still almost nothing on this. And this is actually a very interesting question to really know, but it's not really clear how much it will reduce. And also, it's not the only main issue. Like also, even water emissions or nitrogen oxides are important in that sense. So. Not clear.
Okay, and just to understand that, when you say black carbon, is that the same as soot, or is there
so they are used.
different?
They are kind of used in when you see studies on this. They are kind of used as the same. In that sense, there's almost no difference in this. Like when they, but also probably it's mostly from lack of understanding of specifics on it. It's also very difficult to measure it for a rocket engine.
Yeah. Yeah, because my kind of knowledge of that is it can affect, like in the Arctic, where we've got ships emitting black carbon, it sort of sticks to the snow and it increases the amount of heat that's absorbed by the sunlight rather than reflected. I was wondering, like with that black carbon umbrella, does it sort of absorb the heat there and it sort of stays in the atmosphere rather than reaching the land, but then it still has that warming effect on the layer of air? It looks very high there. You put like 100,000 times CO2.
Yeah, that's what it was estimated. Yeah, it depends. Like then there's this kind of at least when they have the studies on climate impacts. For me, I'm not an expert on all this, so I really not know the specifics. But there's like kind of you have to do this adjustment in terms of the atmospheric layers of the radiative balance, and it depends. So it might be warming the stratosphere, but still it's not clear if it really like warms overall the planet. But still it affects the climate in different ways through changes in the weather, for example, or the currents, everything. And it's kind of similar. I mean, there's the only thing that you could find in the literature related to like black carbon emissions and influences on the weather is like in terms of the studies that they do for geoengineering, or even like kind of even nuclear winters, which they also, it's kind of because of the huge emissions of black carbon in the stratosphere, but still the uncertainty around it it's enormous. Like this is still not really clear what will happen, and it depends on specific compositions. So this is kind of, they really think that in terms of rockets is kind of an uncontrolled geoengineering experiment.
Yeah. So. Okay, thanks. So yeah, other people feel free to chip in with a question, or if you want to add something to the conversation as well. You can see that there's one question from Manfred, who's saying, ESA, so that's European Space Agency, isn't it? And other space agencies have been communicating strongly on their view of the significant benefits of space tech for climate change knowledge and related studies, while you, on the other hand, you're underlying the uncertainty on the climate impact from space itself. So in your view, should the ESA and other agencies also be more cautious in how they communicate, I suppose, their benefit to the climate or their potential impacts?
So of course, not sure about all this, but so of course, I mean, there's these benefits that you get from, especially from the climate observation and everything. But in terms of the space sector itself, there's a lot of things that happen, like that you can do. I mean, you can use it for climate observation, where probably there's a lot of benefits. There's many other applications that are quite useful. It always also depends on the application that you get. So maybe you are using it for space tourism. So then the relative kind of importance in terms of the impacts you cause and also the mitigation you get from it changes. So it's difficult to really know what to think about this.
Yeah, I suppose I'm not really aware of how much the space sector kind of talks about itself being a climate leader, whether it's saying it's doing everything it can do, or is there how much communication is there around like we're reducing our climate impacts? You know, you mentioned the life cycle stuff, so we often see it in the aviation sector talking about using more sustainable materials for the manufacture, but then we kind of don't really talk about the climate impact of actually flying as much. Is there that kind of communication from the space sector?
So I think it varies a lot depending on the actors and everything. It's I mean, there's been a lot of like at least increase in terms of what is the communication in terms of all these issues, especially like in the European, for example, the European Space Agency has like a dedicated office for all this in space, and they are like, is probably one of worldwide, is one of the main actors in all this, and it's well, they are moving this field quite fast, but still is of course it really depends on where, and
yeah. Something that was a bit surprising to me on the your chart for showing the number of launches between now and 2050 and potential increases. It seemed, that one, I don't know if I'm reading that, but the white dots are the payload mass launch, so it's basically like the number of launches, and it is sort of increasing, but the kind of expectation is it looks like it sort of levels off in the 2030s, 2040s. There isn't like it feels like maybe more likely you might see more and more. Why do you think it's because kind of increasing the next 10 years and then stopping?
No, because this study, I didn't say it clear, but it's like what we were doing is on current, we were only assessing what are like current proposed launches in terms of the missions that are claimed now that they will happen. So probably they are mostly in terms of the next, to do them in the next like 10 years, 20 years. But still, they are not speaking about we are not forecasting like how many will be announced in 10 years from now, so that will happen eventually. So one can continue, one can expect that maybe they continue to increase or not. This is only based on like what is claimed up to now. So it's not really a forecast.
Yeah. Okay. Yeah, that's fine. I was kind of thinking, how do you have data up to 2050 about how many launches there'll be? Because my thought was, particularly with the sort of Starlink satellites and stuff, it would be going up and up a lot.
And then it sort of stabilizes because you also have to keep these mega constellations, because some things re-enter and everything, so you kind of need to keep it. But this is only on the announced current mega constellations. Maybe things change.
Yeah, okay. Julian's saying he's just asking about where you can find references. So I think you've put references at the top of your slides, right? And we can share.
So this is all referencing to our 2 papers that we had on this. You can, if you're interested, you can maybe go in. I'm not sure if you can see them, because for me, I see the Zoom thing on top, but you can check them. There's more detail there, and it points to, well, we cite all the main studies on all this. There's also some very important studies I saw is from Martin Ross, it's the kind of modeling of this atmospheric impact. They have a lot of papers on this, so that's also an interesting source if you want to check more details on it.
Okay, and I'll put the recording of this on YouTube, and I can also, Guillermo, if you send me some of those links, I can put them in the video description. And also, I suppose you could comment on the LinkedIn post with some of the references for people. Christoph is asking, the PB is to have shared metrics in Europe or the world to measure the impacts with high level of confidence. Do you know studies that are progressing on this topic to converge on it? I suppose that's what you're working on. And then the question is there anything else?
Yes, I'm not entirely sure what PB means. I guess you assume in terms of the like characterization factors, for example, that are used in terms of like climate change impacts or ozone impacts and these things. There are, the thing is, like in terms of the life cycle assessments, there are some common metrics that are used worldwide for this. The only issue is, at least for this ozone and climate impacts, is still not really clear if they are the right ones in that sense, because the high altitude effects and these non-CO2 issues. So, for example, the global warming potential that you apply for black carbon emissions, for if you emit them on the ground, the value that is reported in the IPCC is different than the one you see in like studies for aviation. that is higher because it's just emitted somewhere else. The context is different, so it has a different impact. And for launchers, this will be significantly different in that sense, but it's just not really clear what to use in terms of the metrics right now.
Okay, thanks. And yeah, your work is kind of trying to improve some of those uncertainties, isn't it?
Yes,
Julio, did Julio have your hand up as well? I think. Was it Julio Betancourt? Did you have a question you want to ask?
Yeah, thank you so much, Guillermo, for this presentation. It was really interesting. My question is more related and maybe not in Earth, but right now there is a bunch of companies trying to be that are more worried about in the outside of the Earth, meaning that trying to take all of the trash that these satellites leave and trying to push this trash outside of the I don't remember their name, sorry. But what are your thoughts about that? Does it really matters? We really need to be worried about all of these trash is staying outside. Is it affecting also this environmental stuff also, or it's not at all related? Thank you so much.
Yeah, no, it's complex, but it's actually related also in a way. But yeah, it's concerning actually the amount of space debris that is up there, and it's reaching a point that you're already seeing some assessments that even if we stop launching right now, the amount of debris will continue increasing simply because of the collisions and everything over the years. We are also speaking about long time scales, but over the years, this is kind of what is kind of named the Kessler syndrome. So there's already some people think that we are already there, like reaching this Kessler syndrome or inflection point, that there's so much up there that just keeps crashing against each other and developing more debris and more debris to a point that it's just too much, we cannot handle. So it's also quite important also to remove it, and not only to remove it, but also to kind of design the spacecraft in a different way so that we can, so they, for example, they to passivate, so like to remove the chances that they for example explode, or they create more debris, or put them in different kind of orbits so that they're called of a graveyard orbits where it's less concerning maybe there, or even re-enter the spacecrafts. This is kind of the best strategy seen up to now, for just to, at the end of your life, to do something to return everything to the Earth, and they burn in the atmosphere, which brings to that is also related to this impact in the climate impact, the atmospheric impact that it will have. So they are already seeing that this might reach rather soon the amount of, because of the amount of spacecraft that will be re-entering, the amount of material that will be injected in the upper atmosphere can be reaching already, can be surpassing what is the natural injection of from like meteorites and things like small meteorites. They always enter the Earth annually, so there's a certain amount. So we might be reaching a point where more things are re-entering because of our spacecrafts than because of natural sources, and the impact is still also unknown. So it's quite important. Like, we have to tackle the space debris issue, but also be careful not to create another one at the same time. So it's not only about removing, maybe even eventually reusing, recycling, I don't know, but how sustainable everything all this is quite, it's a super tricky topic.
Yeah, thank you so much. One last, please. Thank you. Do you think the solution is stopping using spacecraft, sending satellites, because we are worried about the climate change? Do you believe this is a solution, stopping doing that, or we just need to reduce or finding new materials? I don't know. I know that you have been doing this research for many years, so that's why this question about.
What was the first thing you
Do
said?
you believe that we should stop sending spacecraft and satellites outside?
No, I mean, what is important also to say, like, up to now, the current issue, like the current impact is not that big in terms of the global, what we are like other sectors and everything, like we're speaking about maybe even 0.00% of global aviation or so. It's like a very small field. The issue is when we start to increase this and what is might be happening. So it always depends, I guess. Like at some point, as in every field, we will have to prioritize, no, in every sense, what we launch for, what we not. Also the same with aviation, or so it's the same with any other field, any other sector. So it's always tricky in terms of we should continue or not, or we should just rather do it more efficiently and more strategic thinking and considering more any way of also reducing the impacts. Maybe there's some things that can help in a way, maybe not reducing to zero, that's impossible, but there's always something you can do.
Yeah, it's kind of the same challenge we've got in aviation, is need to make things have a lower impact. We're trying to do that all the time, but also every flight and every space flight has an impact, and we need to be careful that we are like maximizing the use of them for society and minimizing those impacts. So yeah, on that note, I think just aware we've reached the hour mark and people probably have other meetings to go to and things. So thanks everyone for joining, and thanks particularly to Guillermo for providing this presentation and sticking around for the questions and answers afterwards. I'm just going to stop recording, but if you do want to check out the recording of this talk, it's on our YouTube channel. I'll be putting that up in the next couple of days. There's a link to that in the chat, so check that out, and feel free to put any messages and emails to us in the future, and we'll get back to you. So yeah, thanks everyone, and enjoy the rest of your day.